Hello, grade 11s. So we carry on today with exponential functions. Yesterday and the day before we were sketching them, and today we're going to work backwards to find the equations of them. Now, the interesting thing is that the form we use is y equals a b to the x plus q, unless otherwise stated. So essentially, we've left out the plus p. Now, the reason why we've left it out is very interesting. And if you don't get the rest, it's fine. But I just think it's also very interesting how we play around with exponents. So the p value can be eliminated by rearranging the formula. And I'm going to show you with an example here. So if we have this formula here, if we compare it to the standard formula, it would be, remember, y equals a times b to the x plus p plus q. So essentially, if we compared it, a would be 3, b would be 2, p would be plus 2, and the q would be plus 0. That's just, yeah. So now if I rearrange this with my knowledge of exponents, remember we can break this up to be 2 to the x times 2 to the 2. Now, because this is a number, 3, and this is a number, I can just times them together. So 3 times 2 to the 2 is 12. And 12 times 2 to the x then is going to be the same as my original. Interesting, hey? Just playing around with your knowledge of exponents. In other words, these two here, y equals 3 times 2 to the power x plus 2 is equal to 12 to the 2 to the x. I've just proved it. And if you go and sketch these now, either using your knowledge of how to sketch exponentials, or if you check it out on Desmos, they will be the identical graphs. They're just different forms of the same equation, and therefore will draw the same thing. And that's why we don't need to worry about p. So if we move on to our first example here, find the equation of the following exponential curve. Now, before we even start, I want you to try and remember our standard equation. Y equals a b to the x plus p, which we don't use, plus q. Now, immediately, asymptote is 6. So that can be 6. And then we've got this point here to substitute and this point here. Remember, points to substitute are always very useful because we then have an x and a y that we can sub in. Now, one little comment before we go to the solution is always substitute the y-intercept first before we substitute this other random point, because the interesting thing is that would be the point 0, 4. And the fact that x is 0 and I put it there, anything to the power 0 is 1. And so in a way the b cancels out because b to the 0 is just 1, whatever b is. So that's why we always substitute the y-intercept first. Okay, I hope you followed that. We're going to now, actually there's a worked solution down here. Let's get rid of that. Okay, so now that's the question. So we go here to our solution. So like I said, we start off with the standard equation. Y equals a times b to the x plus q. Your asymptote, we can see clearly, is 6, so we put plus 6. Then we substitute, like I suggested, the y-intercept first, because the y is going to be 4, and the x is going to be 0, and b to the 0 is going to be 1. And you can follow that through. You just solve, and we get a equals minus 2, and we stick it back into the formula here. Now, we're still not finished because x is still unknown. No, I'm talking nonsense. We need x to be x. B is still unknown. So we substitute our x and our y to a neg 12 in place of y. We put minus 12. In place of x, we put 2. We solve out and we get b to be plus minus 3. But you know that b can never equal a negative number. So that is not valid. So b is 3. And therefore, that is my equation there. Okay, I think this is quite easy, huh? Let's add this x and y back there because I think that's useful to remember. Example 2. Now, in the following sketch, the graph of y equals 2 to the x plus p plus q is shown. Now the interesting thing here is that they've given us b. B is going to be 2. And they've put a plus p in there as well. We don't ever use that plus p unless they ask it in a specific question like they have done here. So we are going to use our asymptote and a random point. So let's do this. So we have our solution here. We know that the asymptote is, let's have a look, that dotted line is at 1. So that means that q is going to equal 1. Substituted in. Our random point for x and y is going to be 0 and 3. So in place of y, we put 3. In place of x, we put 0. Solve it out, get p to be 1. So if p is 1, we put it in place of p over there, and we have our answer. Okay, really easy. And now if you can go and practice on page 80, exercise 5, D and E. The memo's already up, so once you've done it, go and check that you've done it correctly while it's still fresh in your mind.